Hello and welcome to another Left Seat Culture video. Again, another video from the archives for my PPL Ground School series, and this one is around meteorology. So again, taking you through kind of my process for studying, how I found the exam, what results I got, and kind of the little bits and bobs that I might have struggled with. Hopefully this video is helpful to you. So again, I think I took this February, March 2022. So back over to previous me. In this video, we're talking about the ongoing progress of my getting the private pilot's license here in the UK, and I have passed my meteorology ground exam. So I thought to explain to you what my study process was, how I went about passing, some of the struggles I've had, and how it may or may not, hopefully, help you pass yours. So if you've watched other videos on my PPL journey, my ground school process is remaining pretty much the same. It seems to be working, so I'm sticking with it, and we'll see how we get on. So I just provide a quick kind of reminder on that in case this is the first time you're watching one of my videos. So I bought these Pooley's ground school books. I got them off eBay because they were cheap. I think I paid like £80 for the set. But they are older books. So this one is Air Law and Meteorology, and it was published in September 2017, so the 14th edition. So quite old, but still valid. Again, I'm not an expert, but in my brain, you know, meteorology is meteorology, and it encompasses about half of this book. So even though it doesn't look like a lot, I've got to be honest with you, meteorology has been my hardest exam so far on this whole PPL journey. So my process is I read the Pooley's book from page to page all the way through. I don't actually do any of the practice exam stuff in the book. I just move straight on to EasyPPL. If you're not familiar with what EasyPPL is, it's not an app, it's a website. You look at it on your computer or on your phone or on your iPad, so you can do your kind of training anywhere you have an internet connection. I then go through each one of their slides, again, on meteorology. So I went through all their slides and their interim chapter tests. And then at the end, you get to do, I guess, their kind of formal mock meteorology exam. I go through that, fail lots of the questions, especially to start with. Look at what I got wrong. They then give explanation as to why you got it wrong, and then I kind of go back. I have a look back in the book for the things that I didn't do too well on, and try and get that back in my mind, and then also go back to the EasyPPL slides, search back through and reread. And basically I rinse and repeat that whole process many times until I get to a level where normally I'm looking for 90% plus in terms of how I'm getting on, and I'll put some information down below basically on my statistics for the study you know, for the meteorology exam. So obviously I read the whole book, and then this is how much time I spent on the EasyPPL website, both reading through the material and doing the exams. So I did pass the exam. I got 87%, which means I got 2 of the questions wrong, which we'll touch on in a moment. If I can find a piece of paper, I did make a note of how long you have. From memory, I think there was 14 questions and you had 40 minutes to do it in, something like that. But yeah, I got 2 questions wrong. And the 2 questions in terms of the categories which they related to was altimeter and altimeter settings. So I think I kind of got the question back to front in my head or something. I've mentioned this before. The exam phrasing is sometimes a little bit ambiguous. So I'm pretty sure the question was going to be something to do with temperature and altitude changes and how that may mean that your altimeter is over or under reading. Basically, if the pressure setting remains unchanged, your altitude is going to be indicated as being higher than you actually are. So I think I know the answer to this, but clearly answered it wrong. And then there was another question which related to turbulence and the effects on flight avoidance. And this was a really weird question. I remember it said something like, if you have vertical turbulence or vertical, if the thunderstorm generates vertical wind or something, what would happen? So I basically selected the answer that it would affect the lift of the aircraft. So if you're getting kind of strange, vertical wind shearing that's dropping in and out and whatever, obviously that could affect your flight speed, and obviously then the lift of the aircraft. So that may be an issue, but apparently I got that wrong. Obviously, when you get the questions wrong, you don't find out what the answer should have been. You just get the random syllabus objectives mark that you then have to interpret yourself. So for this, for me, was 050.02.01.02 and 050.10.02.01. And you can look that up on the CAA website, and it tells you basically the kind of questions that you're going to be asked. So in terms of the struggle that I had with it, part of it is a personality thing. So, part of my brain is like, if those clouds don't look good, or it's a thunderstorm, I'm not going to fly anywhere near them. So I don't really care whether it's a cumulonimbus or a lenticular cloud that's over a mountain ridge or something like that. But obviously, got to get your head out your butt and focus on kind of getting on with things. But I tend to use these kind of little record cards, and I will write out all the things that I'm struggling with as I'm going over and over the revision. And then I basically will keep these in the car normally, and when I'm driving around sat in the car waiting for my kids to come out of school or something, I will start to read through these. So I thought I would read them to you so that you know the things I struggled with. And again, there's a couple of things where I try to develop a little system that kind of helped jog my memory on it. For example, when we go back to air law, one of the things that I would remind myself of is Q and H. H is not height, it's altitude. So I knew that Q and H was altitude and QFE was height, as an example. Little things that I would do to try and make my brain remember that under exam conditions. So I'll read you through some of these things, and they may or may not help you, or at least if you're struggling with this, know that you weren't alone. And with a lot of these, actually, the exams, I thought air law was hard. Meteorology was definitely the hardest for me, but start off frustrated and thinking, I'm never going to get this. And I try and give myself a month is the time frame I try and work toward, just over a month to study and pass the exams in addition to work and everything. So talk about the things. So first thing was some of the weather reporting mechanisms. So you got Volmet. So Volmet is an in-air METAR reports. So that was something that, for some reason, I struggled to remember that. And again, that Volmet, even now, I didn't have something that clicked in my brain with what that meant. Then you have GAMET, which is the Met Office Regional Forecast. And then you have AirMet. AirMet is really the same thing as GAMET. So Met Office website you can go to and get those Met Office regional forecast reports. Then these two are close together and are related. So a couple of things that might trip you up. One is the troposphere. So what is the troposphere? And this is where basically most of the flying occurs. And then there's the tropopauls, which is slightly above that. And the question you tend to get asked around there is, what is the distances from the poles and the equator? Now the answer is the tropopauls is 9k at the poles, and 9 kilometers and 18 kilometers at the equator. So the way I remember this is 9 is a bit like a P, it's a backwards P. So 9 kilometers at the poles. So 9 and P is poles and 18 kilometers at the equator. Then the different types of clouds, I gotta be honest, I kind of struggle with those, and it was just looking at pictures over and over again and kind of having, I don't have a photographic memory, but try and then remember the picture of the cloud to then remind myself of what it was. So Cumuliform clouds, they're heaped, kind of cauliflowery typed clouds. There's the cirriform clouds, they are wispy and wavy and quite a light cloud. Then you've got the stratiform clouds, they're the layered clouds and cover a very wide area. Then you've got lenticular clouds. Now these ones are a bit easier to remember once you get it in there. So lenticular clouds are always on the tops of mountains and kind of wavy in shape. Then you have the cumulonimbus clouds. So they are clouds that will have heavy showers but of short duration. Then you have nimbostratus clouds and they have prolonged rain. Then you have stratus clouds, and that's basically overcast cloud, which is very common here in the UK. Then in terms of the types of clouds that you might have, in terms of the type of atmosphere you have, so if there's a stable atmosphere, you're going to have stratus and cirrus clouds. If you have an unstable atmosphere, you're going to have cumulonimbus, cumulostrato, and lenticular clouds. And also in terms of understanding cold and warm sectors, if you have a cold sector, that is when cold air is passing on a cold front. And that, I think that kind of sits in with the unstable atmosphere. You must have rotor clouds and cumulonimbus clouds as well. So again, I'm not an expert on these things. I'm just sharing with you some of my experiences. In terms of understanding pressure and temperatures go from high to low. And one of the things that I've written down here that to try and remind myself is high to low, down you go, cold kills. So basically, as you're going down, your instruments may not be reading correctly, and if you obviously screw up, you're going to die. So you want to kind of keep that in mind. So that basically, for my reminders, you may be lower than your instruments are telling you. So you want to make sure you check and adjust that. Another thing, again on my notes here, free wind. So free wind is at 2,000 feet and it's typically twice the surface speed of ground wind and around 30 to 40 degrees angle of more wind. Radiation fog, so there's a couple of different fogs here. So radiation fog occurs when there's been a night, clear sky, high humidity and wind of 5 to 7 knots. Advection fog. This comes from a moist air mass over a cold surface and is relatively easy to predict. Then we have hoarfrost, so this requires light wind, clear skies, moist air, night cooling of around 0 degrees centigrade and also potentially thunder. Then when we look at some of the stuff on the plane itself, so piston icing, so this will happen from an extreme cold with low humidity but also a high power setting. That's one of the things that my brain would kind of get confused about. But obviously in the cold, you need the heat to generate the moisture. So then obviously for carb icing, you need to have positive OAT to create that water vapor. Again, a bit like the piston icing we mentioned before. Moving on again to thunderstorms. So thunderstorms, we will have a gust front, heavy precipitation and potential icing. And remember that a thunderstorm needs water vapor and an unstable atmosphere is upward lifting and the colder the better. So I've put there a couple of winds, geostropic wind. So these require or has pressure gradients and Coriolis force. Those things together is going to equal geostropic wind. Orographic lifting. So this is clouds formed by air being forced upwards. The Foehn effect is the cloud base and the temperature is lower on the ground wind side. This is a question that came up quite often. So where you have wind that's kind of sweeping up a hill on the lower side, you will have some rotor winds, but typically the clouds are going to be higher and the temperature is going to be higher. So it's going to be nicer weather on the downwind side of the hill. Bayes' ballot law is another thing to remember. So when you're facing into the wind, left being high and dry will be clockwise and on the right will be the low pressure and that's anti-clockwise. When you look at some of these graphs, so what I made, and I appreciate this is all over the place, this is just my notes and may or may not be helping, we'll see what you think of this video. When you look at some of the Met Office charts, when you see blue on there, that is the rain in millimeters per hour. And on some of those radar images, where there's a white radar image, this is the temperature of the cloud tops. So the whiter the clouds, the higher those clouds are. So that's obviously helpful for VFR flight for sure. A couple of other acronyms that you'll see on things that took me a little while to get my head around. So when you see COT or COT, that is the meaning for coast. When you see LAN, so LAN, that is land. And MON, MON, is for mountains. Whenever you see something on one of the weather charts that says no SIG, that equals no significant change in the next 2 hours. And when you see tempo, that means no significant change in a period of up to 1 hour. So that's it for the one page of my notes. We'll go through the second one. So a few things that I've written in here. I had real issues, I still do a little bit, with some of the lapse rate working out. So I was quite fortunate I didn't have a question on that in my exam, because I'm probably not so confident how I would have done with that. But so we have SALR, and that's the saturated adiabatic lapse rate. Then we have DALR, which is the dry adiabatic lapse rate. So they were just two things I can never quite remember what they meant and how they worked. So I had to do quite a lot of revision on that. And then obviously ELR is the environmental lapse rate. So this relates to the temperature changes as you go up. So typically every 2,000 feet, every 1,000 feet, you're losing about 2 degrees of temperature, I think, from memory. A couple of other things that I think were key, just trying to get my head around. Wind tends to back down as it decreases. So we looked earlier at the free wind. So the wind will back down as it decreases. Roll cloud is something that you experience downwind. If obviously you're flying and a headwind drops, that's something that's even in the what was it in the human performance exam? I can't remember. There was another one of the exams that was similar here, that when the headwind drops, what you need to do is obviously increase the power and lower the nose, because obviously if the headwind has dropped, that's decreasing the lift and stuff that you've got going over the wings to make the plane lift. So you need to add more power and lower the nose. And obviously, where possible, always avoid downdraft. That's going to cause you difficulty issues. Going back to the weather charts, sometimes you'll see VV and then essentially ////. This means that the sky is obscured and a cloud base could not be determined. So you often see this on the weather reports. That basically means you can't see what things are because the sky is obscured. Again, some of these other things that, like my little mnemonic or whatever it is to help me remember things. Again, on the weather charts, you would see GR, and GR stands for hail. And it's another one of those things is, why is hail not H? So my reminder, and this was actually my wife that joked about this, but it stuck with me, GR, giant rain, hail. Other things, so higher humidity air is less dense than dry air and weighs less. If it's warmer, there is less dense air. Air pressure flows from high to low, and as we mentioned earlier, high is clockwise and low is anti-clockwise. The higher you fly, the lower the pressure, and the lower you fly, the higher the pressure. Air flows from high to low, and that's again rated to the pressure gradient force, so with those different forces we spoke about earlier. A warm front is from pressure falling. You have cloud cover increasing as well as the cloud being quite low. On a warm front you have prolonged rain. Warm fronts also have cirrus, cirrostratus, altostratus and nimbostratus clouds. A trough is an unstable air mass, and typically will have cumulus cloud and potentially thunder. High pressure equals anticyclones and poor visibility, along with potentially fine weather but haze and a light wind. High temperatures to low temperature, again as mentioned before, the altimeter is going to overread, the plane is actually lower than it actually is. Warmer temperatures mean less dense air, so this again comes back to some of that environmental lapse rate stuff and the ISO information. So the ISO is 1013 hectopascals at 15 degrees centigrade and negative 1.98, so I call it 2 and you'd be pretty close. When you look at occluded fronts on the weather charts, so they typically have high cirrus clouds descending along with heavy showers and potentially thunder. Rain, ice will fall from warm sectors from a warm front onto a cold, so again you need the heat for that ice and the rain to function. In areas of low pressure, air is drawn towards and rotates anti-clockwise. COL, so COL, is stagnant, non-moving air trapped between high and low pressures. And we'll also have low cloud, light winds and poor visibility and potentially fog and thunder. And in the summer typically will also be associated with a rain shower. Cold fronts are narrower than warm fronts and they move faster than the cold fronts. The cold fronts also tend to have strong winds, unsettled weather and sharp showers. Cold air approaches and slides underneath of warmer air, and a cold front's typical slope is 150, whereas a warm front is 150. And then back again to those environmental lapse rates. ELR is, if the ELR is less than the DALR, then that equals absolute instability. If the DALR is less than the ELR and less than the SALR, then that is conditional instability. And then finally, if the SALR is less than the ELR, that results in absolute stability. I'm getting a headache even just reading through and talking about those ones. So I don't know if it's been any help. Again, I'm just trying to share my experiences with you and let you know if you are struggling with the meteorology stuff, you weren't alone. Just keep plugging at it and you're going to do fine. And I think the main thing of all these exams, I'm not a great exam person. I've made notes now that I can have on my A5 knee board that will help me with some of these things as and when I experience them in real flight. The biggest problem is obviously trying to ram all these things into your brain before you go into the exam. So obviously one thing you can do, I've not done it only because it's going to sound strange, but my brain can't work this way. But one of the recommendations I have read from people is obviously before you go into the exam, literally whilst you're outside the door, have a read through some of these notes and the formulas and stuff, and as soon as you get in, you can obviously then write these from memory down onto a bit of scrap paper so you can refer to them later. For some reason I can't do that because my brain's then too focused on those 1, 2, 3, 4, 5 things, and I then struggle with being able to access all of the knowledge that I've gathered for a subject. So that's it. Probably a long video speaking about meteorology, or just at least my experiences with meteorology exam. Like I said, my hardest one yet. I'm now moving on to air navigation. The whiz wheel is amazing, but it does far too many things to get my poor little brain to understand right now. But hopefully there'll be a video in the future to say, guess what? Boom! Passed the air navigation exam. But yeah, we shall see how we get on. So thanks again for watching. Hopefully the video series continues to be helpful. Meteorology is still something, even to this day, I still want to continue to learn more and more on. I'm actually thinking about doing the weather school training. So if I do that, there will be another video coming on the channel giving my review and thoughts of that, because at least for me, weather is one of those key things that can disrupt your flight as a pilot. So regardless of how much experience you have, I think you can never have more weather knowledge. So stay tuned for that. Consider subscribing if you haven't done already. Again, press the notification bell, and don't forget to like this video. Really help the channel get noticed and grow. And obviously consider joining the Discord channel as well, the Discord group. It's completely free, and we can interact, you and I and other pilots and people in the community, make things better. So hopefully I'll see you in the next video. Take care of yourself, and goodbye for now.